the topics he has explained to you during the last week. First of all, which module is going on now? Which module is going on now? Hello, please respond to me. Which module we are discussing? Still second module, or has he started the third module? Hello? Hello? Okay. What about module 3, ma? Is module 3 started or not? Has he gave a not been started? Sajeev sir, has he started, sir? Any introduction or anything? Uh, what about these things? Okay, happy. Okay, so anyway, we'll start. So I think I want to start from the first point on third module itself. Okay. I think the screen is visible in both the classes. Am I right?
Yes, sir.
Okay. I
Yes,
think
sir.
I am audible. I am audible also in both the classes.
Yes, sir.
Correct? Okay, okay.
Yes,
So
sir.
we'll start. We will start from the third module today itself. Yes, before going for the third module, let us quickly look on to what are the things we have so far seen from first and second modules. Okay, can you tell me what was the first device, first electronic device we have seen from the first module? The most basic electronic device we have seen. What was that? Yes, diode. Have you seen only one kind of diode or varieties of diodes in the first module? Yes, only one diode, only PN junction diode. Any other kind of diode have you
Zener
seen?
diode.
Another variety, another special kind of diode we have seen, Zener diode. And what are the other things? What are the application of a PN junction diode? You can say we have seen some of the circuit based upon a PN junction diode. Am I right? Yes, we have seen one circuit which is yes. What was that? I am expecting all of you to be get responded. All of you, please respond to me. I don't know the status of this one. Anyway, all should respond to me. Okay. Do I want to call anyone and ask to answer, or will you voluntarily answer to me? Yes. Already you have studied all these things. You have attended your exams. Everything is over. Am I right? So, what is the application of a diode? PN junction diode. In what circuit we can use that one? Hello?
Rectifying circuits.
Yes, very good. Rectifiers. In rectifiers, you can use your PN junction diode. And what about Zener diode? Any important application regarding with the Zener diode?
Voltage regulation.
Very good. Okay, it can be used as a voltage regulator. So in first module, we have seen diodes, two types of diodes, its application. Also, some other points that's also we have seen in the first module. What about the second module? After the diode, we went for some advanced type of electronic device. Am I right? So after diode, what is the next category? Which one we have seen? Second module.
BJT.
Yes, BJT. We have seen two kinds of transistors, BJT and what about the next one?
MOSFET.
BJT. Yes, MOSFET. Generally, you can say FET. We have seen FET, varieties of FET. Can you give the full form of FET? What is FET?
Field effect transistor.
Field effect transistor. Okay, FET is a unipolar device. BJT was a bipolar device. FET, many category under the FET. Out of that, MOSFET, it's a most commonly and a popular kind of FET what we are using. So we have discussed about MOSFET, metal oxide semiconductor field effect transistor. Am I right? What are the things we have studied regarding about BJT? Started from construction. Am I right? BJT. Am I right or not?
Yes, sir.
Yes, we have seen the construction. Later, we have seen its operation of NPN transistor. Later, after the operation, we have seen the characteristics. After the characteristics, we have seen the biasing of a BJT. Then we have seen a very important application of a BJT. Not only BJT, for the transistor, we have a very important application. What was that?
Amplifier.
Yes, very good. Amplifier. Okay. One of the most important application of a transistor, which is nothing but amplifier. Can you tell me one more another important application of transistors?
Switching.
Only for, yes, very good. Okay, it can also be used as switch. Switch means it will have an on condition as well as an off condition. Both kind of transistors, that is FET and BJT, they can be using for switching application also. So how far we have seen this. Now we are going to see about operational amplifier, op-amp, okay, and oscillator. Have you seen about these two circuits, op-amp and oscillator? Yes, have you seen? Have you studied in your EC subject? No, am I right? So this is we are going to start. So these things, and finally we will have some special devices. Special devices meaning we have seen diodes, transistor, and something also we are going to see. After that, we will have some devices which can be used for some specific application, such as we have a LED. I know that you all are familiar with LED. Am I right? What is LED?
Light emitting diode.
Light emitting diode. We have seen about the operation characteristics, everything regarding about diodes. Am I right? So what is LED? LED is a special kind of diode, light emitting diode. Like that, we will see about LCD. We are going to see about transistor. So that kind of specific functionality kind of devices, that is will be under the category of special devices. So that also we will see in the third module. Okay. So far the first three devices we have seen. The remaining not two, op-amp, oscillator, both are different things, and special devices. These are we are going to see in which module? Can you tell me?
Third module.
Third module. Okay. So in third module, these are the three things we are going to see. Okay. So we are going to start about the third module. So from which one I need to start? From that previous slide, you can tell me. Yes. What was the first
Operational
thing?
amplifier.
Operational amplifier. So we are going to see about what is an operational amplifier. In the previous slide, it was not written as operational amplifier. It was written with something else. What was that? Was it written as operational amplifier in the previous slide?
OP amplifier.
OPM. Okay, so these are the different way you can denote the particular IC. This is in the form of IC. You can have this one OP hyphen AMP. This way you can represent or as letter OP and P. So these all things are different way of representing this. So this is the operational amplifier. Okay, you can represent this way also, op-amp. Okay. As a short form, you can represent operational amplifier as op-amp. Let us see what are the things we are going to see regarding about operational amplifier. First, we are going to see about introduction to op-amp. What is op-amp? What are its symbols? Okay, like those things we are going to see. The next thing we are going to see about the block diagram of op-amp. Okay, by combining what are the blocks, you will able to generate an operational amplifier. We have seen the operational amplifier of regulated power supply. Am I right? Am I right or not? We have seen the block diagram of regulated power supply. In which module we have seen those things?
First
Are
module.
you remembering those things? In the first module, okay. Regulated DC power supply. There we were having some step down transformer, later rectifier, later filter, finally voltage regulator. So the block diagram represent what are the important circuit or what are the important elements inside any of these particular circuit or device or something. So block diagram of op-amp is nothing but inside your op-amp, what are the important module, what are the important things are there, so that we are not dealing with any kind of circuit or anything. What are main things are there, we will represent everything like a block. So that is the basic things about block diagram of operational amplifier. After that, we are going to see some parameters of operational amplifier. We have many parameters regarding about this particular operational amplifier. Then later we will go for some configurations of op-amp. And finally, we will see what are the applications. Okay, you can use this operational amplifier for so many application. Okay, and unfortunately only some of the important application are only we are going to see in this particular module. Okay, so these are the things we are going to discuss under the category of operational amplifier. So operational amplifier you can represent this way also. These are the things we are going to see in the operational amplifier category. Now we are going to see what is an operational amplifier, what are its symbol, what are its terminal, for what purpose you can use this operational amplifier, all the basic details about operational amplifier. Okay, so before going for what is currently existing the operational amplifier, we are just quickly look on to what are the previous versions of the currently using op-amp amplifier available now. Okay, so we are just going for some history behind this particular device operational amplifier. Okay, so I'm going to start with some historical timeline regarding about operational amplifiers. Can you tell me these things are taken from one of the usually commonly using website? Can you name that one? Usually in which website you can able to see the you can able to see this kind of history of anything? Many are browsing this kind of website. Can you name that one?
Wikipedia.
Very good, Wikipedia. So all these things are taken from Wikipedia alone. Okay, so this is the first thing. It was the first version of this currently using operational amplifier that was at the time of 19 1941. Before the Second World War or after the Second World War? When Second World War has happened? When you got the independence? Before our independence or after? 1941. Hello? Before. Okay, so before the Second World War itself, it was invented. This was name is vacuum tube op-amp. Okay, vacuum tube. Do you know any idea about vacuum tube? Any idea regarding about vacuum tube? You all know regarding about transistor, am I right? Yes, you know about transistor. Can you tell me which transistor invented first, BJT or FET? Any guess? BJT or FET? You can guess. I am asking a guess from your side. BJT or FET? Which was invented first?
BJT.
BJT. Okay, it was BJT. Transistors give some good scope to the electronic industry. So before the BJT, before the invention of BJT, the vacuum tubes were using. Vacuum tubes are nothing but we have some electrodes are available. I know. I think that you know about electrodes. Am I right? Electrodes. Have you seen? Have you heard about that term? Electrodes. In chemistry, you have seen. Am I right?
Yes, sir.
Positive yes. So vacuum tubes, it consisting with a different number of electrodes, and according to the kind of electrodes, there will be some charge carriers is moving. Accordingly, only these vacuum tubes were operating. We are having different kinds of vacuum tubes like triode, tetrode, pentode, something like that. Can you tell me what is the meaning of triode? What is triode? Triode. Triode. Am I right? What will be triode? What does the tri stand for?
3.
3.
3. So that will be what will be triode? Triode stands for 3 electrodes. Am I right? What will be tetrode? Tetrode.
4.
4. Pentode means 5. So that is different number of electrodes are there, and according to those things, it is operating. That was vacuum tube. So this first op-amp, first operational amplifier, it was based upon these vacuum tubes. Okay, so vacuum tubes was using in that time. So probably the first op-amp that was based upon vacuum tube. Okay, vacuum tubes are actually replaced by the transistors. So see here, in this time, in the invention of this particular op-amp, at that time, the transistors were not there. So vacuum tubes were using at that time. So based upon vacuum tube, you were having an op-amp. Okay, so these are only for your better understanding. These are only for your better knowledge in this subject. These are not of your syllabus or your curriculum. For giving better understanding, only these things are we are discussing here. Now later we will have in 1947 a non-inverting input op-amp has been invented. So only one input, non-inverting input we are having. What is the meaning of non-inverting? We have seen, am I right? Non-inverting amplifier we have seen, isn't it? What is inverting amplifier and non-inverting amplifier? What about single stage CE amplifier? What about single stage CE amplifier? Is it an inverting amplifier or a non-inverting amplifier? Hello? Hello? Hello, am I audible? Hello? Hello, students?
Yes,
Yes, sir. Yes, sir. Sir, you are audible.
Okay, okay, sir. So can you tell me What about the CE amplifier, single stage amplifier? Is it an inverting amplifier or a non-inverting amplifier? It was inverting amplifier. What is the meaning of inverting amplifier? What will be the phase shift between input and output? 180 degree. Am I right?
180.
Yes. So that is inverting amplifier. Non-inverting meaning both input and output will be, how much phase shift will be between these two? How much phase shift will be the non-inverting? Hello? 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 What about non-inverting?
Zero.
What about non-inverting? Zero. Am I right? Both input and output will be in phase 360 degree. When two single stage CE amplifiers are cascaded, will it be inverting amplifier or non-inverting amplifier? When two CE stage, what will happen? Will it be inverting or non-inverting?
Non-inverting.
It will be non-inverting, because that means what? If there are even number of stages as cascaded, it will be non-inverting. If there are odd number of stages like 1, 3, 5, 7, like that, if the number of stages are, it is inverting. Right? Where you have stages in multi-stage amplifier. Is it correct?
Yes, sir.
Yes.
Yes, sir.
So here, why I am telling all these things is, here we have a term that non-inverting input. Okay. So in 1947, we have invented an operation amplifier with a single non-inverting input terminal. We will see what is inverting input, what is non-inverting input during the symbol of this operation amplifier. So here a single input was there. Okay, after that we are having in 1947 a chopper stabilizer operational amplifier. Then in 1953 the first commercially available operational amplifier get invented. So this is the physical structure of that commercially using operational amplifier. This is its internal structure. Internally, what are the things available? Okay, so internally, can you identify any of these elements that you know on this internal structure, that is on the right hand side? Can you identify any of these elements that you already know? What are these things? Yes, what are these things? Hello?
Resistor.
MOSFET.
These are resistors. What about these things?
Capacitors.
Capacitors.
Capacitor. Anything else? What about these things?
MOSFET.
Hello, please mute yourself. Please mute yourself. Can you identify this one? Is this a transistor? Is this BJT or FET, something like that?
MOSFET, sir.
No, not MOSFET. These are what? These are vacuum tubes. Okay, we have seen many things. Am I right? So here, see here, still the transistor. Okay, you cannot have a MOSFET, FET, anything at this area at this time, because they were not invented. They were not popularly used at that time. So at that time, a lot what these vacuum tubes were using. So again, these are things based upon vacuum tubes or any that kind of devices. So these are still, it's not having any kind of BAT or a FETs in 1953. Clear? Now later, let's see what will happen to its structure. In 1961, the discrete IC. What is IC? Can you
Integrated
abbreviate this one? Yes, integrated circuit. What is the meaning of that one? Integrated circuit. Integrated. What is the meaning of that one? Yes, integrated. You are something yet integrated. You may be heard about this one, integrated EMTech. What is this one? Integrated EMTech meaning? Integrated MTech or ME. What is its meaning? Hello? Hello? Generally, you are hearing these things. Am I right? Integrated MTech or integrated something. Integrating something. What is the meaning? Integration, you know. It's a very important mathematical operation. Am I right? So what is that one? Integrated MTech. I am asking, I have explained this thing with an example, but if you are not responding, what I will do? Integrated something. Hello? Hello?
Yes, sir.
Yeah. என்னமா integrated MTech அப்படியே தான் கேட்டிருக்கா?
Completion of UG and PG together.
Together, that's it. Okay. Integrated MTech, it's a single course with, if you completed this course, you will have both the BTech as well as MTech, BTech or BE and ME in a single course. That is, it integrated with these two courses. Am I right? Actually, these courses are different one. Am I right? BE and ME, both are different courses. If you going for this kind of integrated courses, combinedly, both will be there. After completion of this one, you are eligible for both these degrees. Am I right? So integrated circuit meaning what? You are having a varieties of many circuits are there. Everything combined. Everything is combined or integrated to a single circuit, or it will be confined to a single IC, single chip. That are said to be integrated circuit, IC, integrated chips. That also it will be known as. So everything, many circuits, many complex kind of circuits, everything we are integrating to a single one, and we are confined inside a single, a particular semiconductor material. So that is generally known as discrete ICs, integrated chips. So inside a chips, what you can see, many things will be, many circuits will be there. Like inside an IC, many, nearly 1,000 number of amplifiers can be there. Varieties of amplifiers can be there. Voltage followers can be there. Level shifters can be there. That kind of so many circuits will be there inside an IC. Then what is the advantage of using this IC? Can anyone tell me? Inside many circuits are integrated, but it is available as a single IC, single device. Am I right? So what is the advantage of having that kind of a device instead of that kind of using complex circuit? What we can do? We don't bother about what are the things inside the IC. We don't want to study what are the complex circuit inside the IC. We only require to know how this particular IC is get operating. If you know how this IC is operating, we don't bother about what are inside the what kind of complex circuit, how these complex circuit are operating, how these complex circuit are integrated inside the IC. That is not our concern. Clear? Our concern is only how this IC inputs, how these ICs are operating. That only as a user, we need to study. Clear this thing? So that is the advantage of having ICs. Instead of any complex circuit, if we have equivalent kind of IC, that's the most important thing. Clear? So in 1961, this kind of ICs get developed. We will show the figure of that one also. Please wait a minute, some issue with my system. I hope my screen is visible. Am I right?
Yes, sir.
Sir.
Okay. Hope, if you can see. Okay, so far we have discussing about how IC is generated. What about the operation amplifier IC, the first one in 1961? Okay, so see here, this is the physical structure as well as the circuit diagrams inside this IC. Uh, on the right hand side, you can able to see the internal structure. Okay, is there any transistors available? Can you identify any transistors is there or not? Is there any transistor available?
Yes, sir.
Yes, yes, definitely. See here, in 1960s, at that area, BJT become popular. So this op-amp, sorry, the vacuum tubes, that older things replaced by this BJT transistor. So operational amplifier using BJT has been invented at that time. This is its inside how it is get connected. See, many transistors, capacitors, many transistors, everything inside they are interconnected to form this particular display kind of IC. Okay, I think this is clear to you. Then varactor bridge kind of op-amp in 1961. That is also another invention. Varactor bridges. These are nothing but DC amplifiers. They can use it as a DC amplifier. Can you tell me what about our single stage CE amplifier that we have seen? Was an AC amplifier or a DC amplifier? CE amplifier we have studied. Am I right? What was my input signal? It was an AC signal. Am I right? Hello?
Yes, sir.
Yes, sir.
Yes. So with the help of this varactor bridge op-amp, you can give some DC signals to this op-amp that is able to amplify the DC signal also. So that is a specific speciality of using varactor bridge of op-amp. Now in 1962, ported module. Okay, these are said to be the model package, ported module package. So this kind of op-amp invented in 1962. Then these are the other varieties of operational amplifier ICs, monolithic IC. Okay, still this kind of monolithic op-amps are still we are using our current days. Okay, even though it was invented a long year before, still nowadays also this kind of monolithic op-amp IC that is also is using. So these are its internal structure. See, as we are going with advances, more number of modules are integrating inside the op-amp. Everything are improving year by year. So this is from MUA 709 monolithic IC op-amp internal structure. You can see many number of transistors, many other elements, everything is integrated inside to form this particular monolithic IC. Yes. And another variety is MUA 741. Still, this is the most popular kind of IC that we are using in laboratory, in all the board development. In all these ICs, this MUA 741 is also this one is we are using. Okay, MUA 741. This MUA stands for its company name. It's nothing but child. MUA 741. MUA stands for fire. What they are having. Not only MUA 741, 741 is the widely available with other manufacturers also. 741. That is also a commonly using 741 variety. Have you seen any kind of LM ICs in our previous topics? Yes, have you seen LM something? Hello? Hello? Hello, am I audible? Can you tell me?
Yes, sir.
Yes,
Students?
sir.
Okay. Then please tell me, have you seen any IC name started from LM? LM something. The same
Voltage
thing we have
regulators.
what was that LM? After LM? The same thing we have done as an experiment also. All right. LM 317 we have seen. Am I right? What was that? LM 317 fixed IC regulator or a variable one? LM 317 adjustable IC
Adjustable.
voltage regulator. It was adjustable voltage regulator. Also, we have seen LM337. There also you can see LM. LM is nothing but it's a manufacturer company name. It is nothing but national. Okay, so National Semiconductor, that's the company name. So they are producing these LM series files. Okay, not only these two, but also high level companies such as Motorola and Texas Instrument. All these companies are manufacturing this 741 IC. So 741 is the most popular operational amplifier IC that is currently. So this is the structure of your 741. Uh, can you identify how many pins are there? How many pins are there? By seeing this figure, can you identify? Can you tell me how many pins are there for this particular IC? Hello? Hello, please respond to me. See, a figure is shown. Are you know about the counting? How many pins you can able to count from this figure? Hello? Please respond to me.
8.
8 are there. Okay. So on this side, 4 are there. On the other side, we have 4. Okay. So can you tell me which is the first pin? We need to give the pin number. Am I right? 8 pin. You told me that there are 8 pins are there. So which will be the first pin? Will this is the first pin, or will this is the first pin, or here also we can have the pin? Here in this side also we can have the pin. So which one will be the first pin? A, B, C, or D? Which will be the first pin? Pin number 1. Any guess? Or is there any way to
A.
identify that one?
D, sir.
Yes, A will be the first one. Very good. A, this is 2, this is 3, this is 4. Which will be the fifth pin? C or D?
D.
Not D. C will be the fifth pin. 5, 6, 7, 8. How you say that it is the first pin? This is the first pin. On what basis you told me like that? Is there any method to identify those things? You can draw your IC like this also. Okay. Top view. Am I right? This is my top view of this particular IC. 8 pin IC. Correct? So how you can identify the first pin? You told me this is the first pin. It's correct one. On what basis you told me this is the first pin? See the figure and at least tell me. Anything is shown near to the first pin? Anything is there near to this first pin? Hello? Hello? Hello, please tell me. Hello? See here, are you able to see this kind of a small circle-like structure? So it's near to the left-hand side. Am I right? This is more near to this first pin. So this will be your first pin. This is the way to identify the first pin in any IC. In some of these IC, this kind of round like small circle won't be there. So how you able to without this one? If this thing is not there, how you able to identify? How you will be able to identify? I think no one is responding to me, so that I can move in a faster manner. So see here, if you have a groove-like structure is there, on the left-hand side, whatever be the pin come, that will be your first pin. Okay, so this is the way how to identify the particular pins. This is the first pin, and also this way will be the pin counting. After 4, 5 will become here, 6, 7, 8. So 741 is available as an 8 pin IC. Clear? Okay, so these are the varieties of structures of 741. I hope I am audible in both the classes. My screen is visible in both the classes. Am I right?
Yes,
Yes,
sir.
sir.
Am I right? Okay. So this is the internal structure of your 741. Okay. So this was the historical timeline, and also later after the invention of this FET transistors, they also included in this particular circuit structures. See here, instead of BJT, you can add these FETs also, so it will give more performance factors to this kind of op amp. It can enhances the speed of operation. Also, it can use to reduce the size of these ICs. Everything that can be made if you add this kind of FETs to any circuit. Okay. So later, not only regarding about the circuit element, number of circuit, also as we go from the previous year to the current years, the operating voltage that is also get improved. In case of, if you're considering about 741 IC, here what operating voltage we were using was plus or minus 15 volt, or also you can able to use plus or minus 12 volt. So these kind of supply voltages we were using for 741. That was invented nearly 1960s. Now, recent days, the supply voltages, it get reduced to some 5 volt or even 3.3 volt, or latest one nearly 1.8 volt. That is enough to an IC to be get operated. Can you tell me, as the supply voltage required for an IC is get reduces, is it a good thing? Is it an advantage or a disadvantage? If the supply voltages get reduced. See, earlier we were having some plus or minus 15 volt. Now 5 volt, 3.3, 1.8, like that dramatic change, reduction has been happened for the supply voltage. Is it a good thing or a bad thing? If the supply voltage is required is reduced. Is it good one? Can you tell me? Hello?
Yes, sir.
Yes, definitely. Because if lesser supply is required, correspondingly, the power consumption will be lesser. Lesser will be the power dissipation. In those aspects, definitely. Okay. So lower the supply required for any IC, any microcontroller, microprocessor, or anything, it will be better for its power consumption or all other performance factors. Okay, so see, and in our discussion, we are considering about this 741 ICs also. That means our supplies will be nearly some plus or minus 15 volt or plus or minus 12 volt, like that. Okay, so these are the supply that we are going to discuss in our syllabus. So we are considering about 741 and with these kind of supplies. So these are the just historical timeline that I want to convey to you. These are for your better understanding only. Now we are going to start about what is op amp. Can you tell me what is op amp? What is the actual name for this one? Op amp. What is OP? OP
Operational
stands for?
amplifier.
It is operational amplifier. So definitely it is an amplification. It's a device, or it's an integrated circuit that providing amplification. What is the meaning of amplification? What is the meaning of amplification? What is amplifier? What is amplifier? Can you tell me? Don't know? What an amplifier will do? Hello? We have seen single stage C amplifier, single stage CS amplifier, multi-stage amplifier, all those things we have seen. After all these things, if I am asking what is an amplifier, no response. Yes? Yes, increases what parameter of input signal, ma? What parameter? Will it increases the frequency or anything else like amplitude? What parameter of input signal will it be? Yes, ma'am. Very good. Amplitude, that's it. Okay, that is important. Not you should not tell that increases the input. It increases the amplitude of the input signal. Okay, what are the varieties of amplifiers we are having? If the amplitude of the input voltage is get increases, what amplifier it is? If the amplitude of the input voltage, yes, will it be current amplifier?
What happened to the A class students?
Sir,
Hello?
very poor response. No one
Hello,
is
Dave.
answering.
See, just now I got vaccine. Some other faculty coming and helping to us. Why can't you interact? I don't know. என்னடா பிரச்சனை உங்களுக்கு? ஹலோ, எல்லாரும் தூங்கிட்டு இருக்கீங்களா?
No, sir.
No, sir.
செகண்ட் ஹவர் தானே, அதுக்குள்ள என்ன தூக்கம் உங்களுக்கு? அவர் எவ்வளவு இன்ட்ரெஸ்டா எடுத்துட்டு இருக்காங்க, கொஞ்சம் இன்டராக்ட் பண்ணலாம்ல? ஆம்பிளிஃபையர் நம்ம படிக்கவே இல்லையா? ப்ளீஸ் இன்டராக்ட். அட்லீஸ்ட் யாரோ 1 or 2 வாயை தர தயவு செஞ்சு. ஒரு கிளாஸ்க்கு வராங்க. இந்த கிளாஸ் இவ்வளவுதான் போர் அடிச்சுட்டு போயிடுச்சுன்னா அடுத்த தடவை ஆல்டர் பண்ண வேண்டான்றவாங்க கிளாஸ். ஓகேவா? கொஞ்சம் இன்டராக்ட் பண்ணு.
Okay. So, hello, students, shall we continue?
Yes, sir.
எஸ் சார்.
Okay.
Yes, sir.
Okay. So, where were you, these students? If sir is coming only, you will open your mouth. Is there anything like that?
No, sir.
நோ சார்.
Okay. So, please respond to me, student. Okay. I'm also passionate to teach you this kind of subject to you. Okay. Please respond to me. So, now please tell me if the amplitude of the input voltage signal is increased. Is it a current amplifier or a voltage amplifier?
Voltage amplifier.
It is a voltage amplifier. Current amplifier meaning amplitude of the input current signal will be increases. Okay. So op amp, which you already told me that it is operational amplifier. So it's an amplifier. Definitely it will amplitude. It will increase the amplitude of the input signal. Then what is the first term? Operational amplifier. Okay. So op amp, its abbreviation is operational amplifier. Can you tell me what will be the meaning of that one? Operational amplifier. Operational stands for what? I will tell you, it can be used to do many kind of operations. Operations can be do with the help of this particular amplifier. For example, most of the mathematical operation can be do with operational amplifier. Can you give me some examples of the mathematical operation that we are having? Mathematically, what are the operation we can do from the basic things?
Subtraction.
Yes. Yes, very good. Addition, subtraction, anything else?
Multiplication, division.
Multiplication, division, then what about this one? Differentiation. What about this one?
Integration.
Integration. What about this one? Rectifier. Am I right? Half wave or full wave? Full wave rectification. Am I right?
Yes, sir.
What about this one?
Amplifier.
Amplification. For all these things, you can use your operational amplifier. It can be used as an adder. It can be used as a subtractor. It can be used as an integrator. It can be used as an differentiator. It can be used for your what rectifier, half wave rectifier, full wave rectifier. What about this one? What about this one? Shaper. One more name we have studied. Shaper is very good. That's the proper answer. We can also have one more name. Upper portion get clipped. Am I right? So what will be that one?
Clipper.
Clipper. Yes, very good. So it can be used as a clipper. What about this one? What about this one? This is my input signal. This is my output signal. Input signal have DC values of 0. For output signal, this is my 0. So what will be this signal? What will be this particular thing? We have seen this as the application of diode. Actually, what happened to the signal? Is any portion of signal get cut off? Any portion of the signal is get clipped off?
No, sir.
No. Whatever be the signal, that is as such is getting as the output. But what is the difference between input and output signal? It gets shifted. Am I right?
Yes, sir.
Yes, sir.
To the upward side or the downward side?
Upward, sir.
Upward. So what is this kind of circuits are known as? Clamper. Am I right? Clamper. Have you studied that term?
Yes, sir.
Yes, sir.
Yes. So clamper. These are positive clamper. Positive clamper, or also you can call it as level shifter. Am I right? Level shifter or level translator. What is the meaning of level shifter? Level. What level is shifted there?
Upper level.
Not upper level, actually, the DC level. Am I right? The input having this DC level of 0. The input signal was symmetric about the 0 volt. Am I right? What about the next signal? It is shifted upward. So its level, DC level, gets shifted. It can be for upside or the downside. So level shifter or level translator. Level is translating. So for all these purpose, which device you can able to use? This operational amplifier is capable of use. Correct? That's why it has the name operational amplifier. Clear? Why
Jayadeva
we
sir,
have the name? Hello, sir.
sir, if you are using white color marker means it will be good to see in black background, sir.
Okay, okay, sir.
Okay, okay. Sir.
Okay, sir. So this is the meaning why we have the name operational amplifier. Then multi-terminal device. We have seen an IC package of 741. Am I right? How many
Yes, sir.
terminals were there? How many terminals were there for that particular IC?
8.
8 terminal. Okay, so definitely it will be available in form of multiple terminals, not a single or one or two terminal. Many terminals will be associated with this particular operational amplifier, and also it will be available as a IC form. Internal structure we have seen. Am I right? We have seen the internal structure of many varieties of operational amplifier. Am I correct? Was it very simple
sir.
one?
No,
Was it
sir.
very? Yeah, it was very complex. Am I right? Many circuit, many devices were there. Everything is integrated together. So inside is very complex one. But outside, what you can able to see? Outside of your IC, only some pins. Only that thing you can able to see. And also its operation, its behavior, its working. Everything is very easy to study. So that is the importance of having ICs. So it is commonly referred as operational amplifier. As I told this point before itself, what As a user, you don't bother about what are the integrated IC, integrated circuit, what are the complex circuit available inside IC that are not required to study from your side. Your concern is only what are the pins available on the IC, what are the input or from which pin you need to take the output, what are the supply voltage you need to give to the IC. Only these thing is only your concern. Okay, you are not want to bother about what are the elements, what are the transistor, how many transistor, what are the circuit, etc. available inside the IC. So that is the importance of using this particular ICs. Okay, so these are the varieties of package what we are having. It's available with metal can TO package. Another thing is dual inline package, and the other variety is flat package or flat pack. This kind of packages, these op-amp ICs are available. The first two format already we have seen. Again, I will repeat. So this is the first thing we have seen. Am I right? Have you seen this particular physical structure before?
Yes, sir.
Yes. Yes. So this is the metal can TO package. Okay. These things will be the metal shields will be there. There you can see multiple terminals will be available to this one. This is its pin out diagram. Okay. See how many pins are there. Can you identify? Can you tell me how many pins are there on this IC? 8 pins are there. Okay. And see, this is its pin out diagram. There, inside this circle, you can able to see a triangular like structure. Am I correct? Are you able to see?
Yes, sir.
Yes, sir.
Yes. So actually, that one, this one, is actually the symbol of the operational amplifier. So operational amplifier is nothing but this one. This is built inside this particular IC like structure. Okay, so all these pins are not using for operational amplifier. We will see what are IN 1, what are IN minus, IN plus, out, V plus, V minus, everything we are going to see only. Anyway, this triangular like structure inside this IC, that is only the operational amplifier. There also you can see able to see NC. Some of the pins are represented with NC. Can you guess what is NC stands for? NC is nothing but no connection. That means this pin is not using for any of our operation. It's simply as a extra one. NC stands for no connection. Okay. So far I told you this is the first package like metal can. Next is dual inline package. Okay. This is the dual inline package like structure. Why we have the name like this? Why the name is dual inline package? What is the meaning of dual stand for?
2.
Dual means two. So two line. What are the two line? Are you able to see two lines here? Two sides.
Yes, sir.
Yes. This is the first side. Am I right? One side. This is the
Yes,
next
sir.
side. So on the both the sides, we will have the pin. Okay. See on the front, on these two sides, we don't have any pin. Only on the two sides we have the pin. Other two sides are without pin. So that kind of package is said to be dual inline package. How many pins are there for this particular IC?
8.
8 are there. Okay. So see again here inside this IC you will have your operational amplifier. See IN minus, IN plus, out, and we can see V plus, V minus, all these things. And also you can see NC. NC stands for no connection. So this is 741 with DIP package. Generally we will say DIP only. We are not using this full form. DIP stands for dual inline package. What about the next thing? Is that again DIP or metal can package? On the right hand side, is it indicates the
Yes,
DIP
sir.
package? Yes. What is the difference between the middle one and the right handed side one? Is there any
More
difference?
number of
Or
pins.
more number. It is available as a 14 pin DIP. Okay, 14 pins you can able to see. Correct? Yes. Then, yes. What I told is, can you tell me for this here? Sorry. How many operational amplifier is available inside this one? How many operational amplifier is there? This is your operational amplifier. Only one. Am I right?
Yes, sir.
Yes,
Yes.
sir.
Then there are some ICs which are available with more than one operational amplifier. For example, suppose this is your IC. There is chances that more than one operational amplifier that is also available in a single IC itself. So that kind of IC packages that is also available. For your information only, I explain these things. Clear? So these are the two packages. How many packages I told you? I told you 3 package. Am I right? So one more package is, this is flat package. Can you tell me why it is having the name flat package? By seeing its structure, seeing its physical structure itself, you can tell me. Flat package. What is the meaning of flat package?
Pins are flat, sir.
It is look like a flat. It's a single like a paper. Am I right? If a paper is placed on the surface, like a 2-dimensional one. Am I right? What about the previous one? There, the pins, everything were projected outside. So it will be 3-dimensional way. This is what you 2D only. It's parallel to whatever be the board, whatever be the surface, what we are having. It will be always laying on that surface only. Am I right? So it's like a flat-like structure. That's why we have the name flat package. Clear? Yes. Tell me for this particular IC, how many pins we are having? How many pins are there? 10 pin. Okay.
10.
So these are for your information only. So this way you can have. Now we are going to start into the first important things of your operational amplifier, the symbol of operational amplifier. Please look at this diagram in a proper manner and tell me how many input terminals are there.
2.
How many input terminals? There are 2 input terminals. Can you name those 2 input terminals?
Inverting, non-inverting.
Inverting input terminal and non-inverting input terminal. Clear? How many output terminals?
1, sir.
Only one output terminal. Then what will be plus VCC minus VE? Plus VCC, we are very much familiar. Am I right? VCC. Where we have seen this VCC? We have seen VCC. Am I right? Okay, before that, tell me what is VCC? Is it a DC supply or a AC supply or anything like that? VCC? Please recall your second module content. VCC, in many circuits we have a DC supply. In biasing circuit, am I right? In amplifier, in everywhere we have seen VCC. Actually, what is VCC? You told me that it is DC supply. Why we have the
Common
name
collector
VCC?
voltage.
Not common collector. That CC not stand for common collector. VCC stands for collector DC supply. That's it. Okay, collector supply. That means what? In that way, in that point, the collector terminals of this transistor, BJT transistor, we were connected. Am I right? At that side only we were connected our collector terminals. Am I correct? Yes. So
Yes,
VCC,
sir.
that is a collector supply. Then can you guess what will be VEE? What is VEE? E stands for what?
Emitter.
Yes, emitter supply. So yes, so at this point, emitters of this BJT transistor, they will connected at this point. And is it a positive supply or negative supply?
Negative, sir.
Negative.
Negatives. Okay. Okay. So also I have mentioned about if this is my 741 IC, mu A 741 or LM 741 anyway. 741. What I told about the supply voltage, I told you once values for the supply voltage. What was that?
Plus or minus 150.
Plus or minus 15 volt I can use, or I can use some plus or minus 12 volt also. So if my supply voltage is plus or minus 15 volt, what about VCC? What voltage I need to give as VCC?
Plus 15.
Yes, plus 15. Very good. This will be plus 15. What about here?
Minus 15.
Minus 15. Clear? That's it. Okay. So mostly we will give the same magnitude and voltage with opposite plus and minus. Like this we will give. And always it will be plus or minus 15. There are some other IC where what? Here we will have some supply, and this point minus VEV, they may be connected to the ground. That kind of ICs that is also available. But if you are considering about 741, the most popular one, we will have plus symmetric supply. What we will give? Plus 15, minus 15. If I am giving plus 12 volt, that is also possible. I will get minus 12. I want to give minus 12 at VEE. So this is the way. So what about VCC and VEE? They are the supply pins. Clear? So how many input pins are there? All of you please respond to me. How many input pins?
2.
2 input pin. How many output pin?
1.
1. How many supply?
2.
How many supply pin? 2 supply. Okay. Now, inverting input terminal. Correct? Then this is actually the body of your operational amplifier. There you can able to see here we have a minus. Here you can able to see a plus is there. Okay. That means this inverting input definitely should give to this minus. Non-inverting input should be given to this positive itself. Due to this negative is here, we can have one more name for this inverting input, which is nothing but negative input. Or this particular terminal, inverting input terminal, you can also call it as negative terminal. So what will be non-inverting input terminal? Another name?
Positive input.
Positive. That's it. If this is negative, definitely this is positive input terminal. So what are the two terminal? Positive terminal and negative terminal. That is also very easy to remember. Am I right? Yes.
Yes,
Okay.
sir.
And yes, then we are going to see why we have the name inverting input, why we have the name non-inverting input. What I told, what about inverting amplifier? If input is positive signal, if input is a positive going signal, what will be the output of inverting
180
amplifier?
degree phase.
180 degree. So it will be like this. Am I right? Am I right? This is for an inverting amplifier. What about non-inverting amplifier? If this is my input for a non-inverting amplifier, I am telling about amplifier, not about this one. If this is my input to a non-inverting amplifier, what about the first cycle? First half cycle for the output of non-inverting amplifier. This is positive going. This is positive going. Am I right? So output is also will be positive going. Correct? So you know what about inverting amplifier and non-inverting amplifier. Similar thing is, similar concept is here also. Inverting input is nothing but if we have a positive going input at the inverting terminal, if we have a positive going signal at the inverting terminal, what will be my output? This is
Negative.
positive going. Am I right? So yes, it will be negative going input. Negative going output will be generated. So that is inverting input terminal or negative input terminal. If we have a positive going signal at the inverting side, inverting terminal, the output due to that one will be negative going. Clear? Clear this thing? Very simple. Inverting means whatever be the input signal, that will be inverted at its output side. Clear?
Yes, sir.
Yes. Another thing, what about here? Non-inverting input. If we have a positive going signal at the input of non-inverting terminal, due to that, what will be my output? We have a positive going. What about the output?
Positive.
Again, it is non-inverting. Am I right? So output will be also positive going. That's it. So non-inverting, it will not give any phase shift to the input signal. But inverting terminal, whatever be the signal at the inverting terminal, this will provide a 180-degree phase shift. Then that will be your output with respect to the inverting input. Clear this thing? So here, if you have a positive going, output due to that one will be negative going. In case of non-inverting, if we have a positive going, output also will be positive going. Clear these things? Yes. What
Yes,
is
sir.
another name of
Yes,
what is
sir.
another name of what is the another name of positive input? Positive terminal. Sorry. What is another name of inverting input terminal? What is another name of negative terminal? Clear? Then this is my symbol. Okay. Then suppose if I am drawing the symbol of the operational amplifier like this also. Is this correct or not? What is the difference between these two symbols? Can you tell me? Yes? Hello? What is the difference between these two symbols? And again, suppose I am considering that to the inverting input, my input signal is V minus. Here my signal is V plus. Okay. So this is my symbol of operational amplifier. Any doubt in this symbol of the operational amplifier? Any doubt?
No, sir.
No, sir.
Then I have drawn another symbol also. Okay. Is this symbol is corrected? I have drawn a symbol on the top side. Is this correct or not? What is the difference between these two? Can you tell me? Yes, what is the difference between this symbol and the symbol already there in the PPT? No
Negative
difference?
input and the positive input are interchanged.
That's it. Here it is positive, here it is minus. So is this symbol is correct or not? Is this symbol correct? Yes, any guess? You can tell me it is correct, or you can also tell me it is not correct. But please respond to me. Can I use the symbol like this also? Is there any condition that always at the top negative, always at the bottom positive? Is there any requirement like that?
No, sir.
No, you can draw this way also. Okay. So if you draw this way, what will be this particular terminal? What will be this particular terminal? Is it inverting terminal or non-inverting terminal?
Non-inverting terminal.
This is non-inverting. Clear? Yes. So what signal I want to give here? V plus or V minus?
V plus.
V plus I want to give here. V minus I want to give here. Clear? So you can draw the symbol of the op amp like this also. But wherever we are mentioning the positive, that will be the non-inverting terminal. Wherever you are showing this negative, that will be the inverting terminal. Suppose if I am drawing the symbol like this. If I am drawing the symbol like this, is this correct symbol? Is this the correct one? Is this the correct one? Please tell me.
No, sir.
No, definitely it's the wrong one. Okay, we can able to see that from your senior classes only. I am telling from that one. Many are drawing the circuits in a proper manner, but they will forget to put the positive and negative. Okay, so without those positive and negative, that is absolutely wrong one. Okay, so definitely the proper way you have to mention this one. Then only you can able to identify which is the inverting or which is the non-inverting terminal. Clear? So please remember that point also. Definitely you have to mention this plus and minus on the op-amp symbol. Clear? Wherever we have the positive, that particular terminal will be the positive terminal. Positive terminal meaning non-inverting terminal. Clear? Clear these things? Hello?
Yes, sir.
Yes. So that's it. Another very important point I want to share to you is this is a high gain amplifier. I told you that operational amplifier, that means it is act as an amplifier circuit. If you consider about the gain of this particular circuit, it is very high. Gain of this op-amp circuit will be very high. Clear? Please make a note of that one. The gain is very high. Practically the gain of this operational amplifier is very high. We are representing gain with A. Why I am representing A, capital letter A? Why I am representing gain as capital letter A? Is there any reason? Is the second letter is A, that's why. Second letter of gain is A. Due to that, I am representing A, capital letter A. Hello?
No, sir.
Then we have seen, am I right? AV, AI, like that. Am I right? So
Yes.
all are gain,
First-
current gain, voltage gain. Why? Then you should ask why it is A.
First pin.
First pin. A stands for, what is another name for gain? Gain is also said to be amplification factor. Am I right? Yes.
Yes, sir.
So AI, it is a current amplification factor. AV, voltage amplification factor. So that's why we have the name, we are representing with capital letter A. Okay, AI, AV, AP. AP stands for power gain, power amplification factor. Okay, so anyway, here what I am telling is for the operational amplifier, gain will be very high. It is in practical cases. So in case of ideal cases, what will be the gain? In ideally, what will be the gain? Gain is very high in practical cases. So ideally, what is the extreme value of very high? Extreme value, largest value. High, அதோட extreme value என்னது? Maximum எவ்வளவு இருப்போம் ஹைன்னு சொல்லும் போது? ஹலோ ஹலோ புரிஞ்சுதா என்னது? Gain is high சொல்லிட்டு இருக்கு கரெக்டா? So what is the maximum extreme value for a high value? What is the maximum largest number you know?
Infinity.
Infinity. I am expecting this answer from you. So ideally the gain of this amplifier will be how much? That is very important. It is infinity. Clear? So ideal, for an ideal operational amplifier, this gain will be infinity. Okay, we have different kind of gain. There we have some other point also to be discussed. But anyway, so far you should know that gain is very high. Ideally it is infinity. Then what I told to you, how many input terminals we are having?
Two.
How many input terminal? Two input terminal. So here it is mentioned that two high impedance input terminal. Why we have the name like that is, for a operational amplifier, Ri, input resistance, will be very high RO. What is RO? Can you tell me? RI is input resistance. What will be RO?
Output resistance.
Output resistance. Okay. So output resistance is very low. So since input resistance is very high, the input terminals will be having high impedance. Clear? So we are having two input terminal. These two input terminals will be high impedance. Impedance resemble to resistance. Am I right? So high impedance input terminals we are having. Clear? Why it is said to be high impedance input terminal? Because input resistance is very high for an operational amplifier. Clear? Clear?
Yes, sir.
What about output resistance? What about this output resistance?
Low.
It is low. So what about output terminal? How many output terminal we are having?
One.
Only one. So that's why we have the name one low impedance output. Clear?
Jayadevan, sir.
One. Hello, sir.
Sir, am I audible
Hello?
in both the classes, sir? Sir, Jayadevan, sir, am I
yes.
audible?
Yes, sir.
Sir, we can give small task. Hello.
Okay, sir. You can give, sir.
Sir, sir, Jayadevan, sir.
Hello, sir. I can hear you, sir.
We can give one small task to them. Why input should be high, output should be low.
Yes, sir.
Let them
Yes,
find
sir.
it. We can give task to them.
Yes. Okay. So the question that sir is told to you that I told you the property. It will have high input impedance and low output impedance. Okay. So please search why it is so for this particular operational amplifier circuit. Okay. The question is why operational amplifier is having high input resistance and low output resistance. Clear? Then what I told to you, what about input resistance? Is it low or high value? Within 1 minute, I am going to wind up. Input resistance is very high. So what will be the ideal value? What will be the ideal value for input resistance? Infinity. So this is very, very important point. Clear? Input resistance for an ideal operational amplifier. In an ideal concept, input resistance is infinity. What about output resistance? Ideally,
Low.
output resistance is low. So ideally, what is the extreme value for low?
Zero.
It is 0. Am I right? So for an ideal case, input resistance is infinity, output resistance is 0. Then the gain AOL, I will tell AOL that we will see later. That is also infinity for ideal case. Clear? So these are the things I want to convey today. So that's it. So thank you for your patient listening. If you have any doubt, please ask me. Otherwise, you can leave now. Okay. Thank you very much.
Sir, 1 minute, sir.
Have a
Ask them to
delicious
stay
day.
back.
Yes,
Sir,
sir.
ask them to
Gajendra
stay
sir
back for
want to convey
2
to you.
minutes, sir.
Please,
2 minutes,
for,
sir.
2 minutes. You can proceed, sir.
Yes, sir. Jayadevan, sir. Thank you very much, sir. Jayadevan, sir. Am I
Okay,
audible to everyone?
Yes, sir.
Yes, sir.
See, I hope your CA test was over. Am I correct? You finished.